Good afternoon, children. In the previous sessions, we have learned about the Thales theorem, then criteria for the similar triangles we have learned, we have worked out some of the sums. Now, today we are going to discuss about the areas of similar triangles. Based on that, we have one theorem. Let me discuss here. The ratio of the areas of two similar triangles is equal to the square of the ratio of the corresponding sides. So they have given two similar triangles. Look at this now. ABC is one triangle. PQR is another triangle. They have given that these two triangles are similar. That means they are equiangular and the corresponding sides are said to be in the proportion we know very well that. So, now, what is the data here for this theorem? Triangle ABC is similar to triangle PQR. These two triangles are similar. That means they are equiangular and the corresponding sides are said to be in the proportion. Therefore, what have to prove? We have to prove that the ratio of the areas of two similar triangles is equal to the ratio of their corresponding sides. We have to prove. Therefore, to prove that area of the triangle ABC by area of the triangle PQR is equals to squares of the corresponding sides. What are the corresponding sides here? AB square by PQR square, BC square by QR square, AC square by PR square. You need not prove all the three. Any one pair of the corresponding sides you can choose. That is enough. What is the construction here now? Construction. Draw AM perpendicular to BC and PN perpendicular to QR. This is a construction. Draw AM perpendicular to BC and PN perpendicular to QR. Once again, statement of theorem. The ratio of the areas of similar triangles is equals to the ratio of the pairs of the squares of the corresponding sides. There are three pairs. We need one pair of the corresponding side. If you prove that is enough now. Now, data, they are similar. Corresponding sides are taken. Construction are taken up. Let us see. We know very well that area formula to find out the area of the triangle is half into base into height. Where is that? We have to do the sums here now. Look at this now. How we have to go for that? Yes. Here, area of a triangle ABC by area of a triangle PQR is equal as to formula to find out half into base into height. Here AM is perpendicular to base BC. Here PN is perpendicular to base QR. Therefore, half into base is BC, height is AM. Half into base into height. In the same way, area of the triangle PQR, half into. In the triangle PQR, QR is the base and PN is the height. Half into QR into PN. Half and half get simplified. Then we can get here now BC by QR into AM by PN. This is one concept you can keep it. Now let us compare these two triangles ABM and PQN. In the triangles ABM and PQN, you know that angle AMB is equal as to angle PNQ. From the construction, we know that they are perpendicular, they are right angles. So, reason from the construction, yes. And you know that angle ABM is equal to angle PQN. Why? They are equiangular because they have given that they are similar triangles, means they are equiangular. Therefore, we say that angle ABM is equal to angle PQN. This is from the data. They are similar triangles. Therefore, they are equiangular. In these two triangles, we are compared to pair of the corresponding angles. Therefore, by AA criterion, yes, you know that triangle ABM is similar to triangle PQN. Fine. When these two triangles are similar, as we have discussed earlier that they are equiangular, corresponding sides are set to be the proportion we know. Therefore, here corresponding sides here AB by PQ is equal to, yes, AM by PN, which is equal to, you know that, BM by QN also, because when two triangles are similar, then their corresponding sides are set to be the proportion. Equation 1. As you know that they have given that these two triangles are similar, so their corresponding sides are also set to be the proportion. So we know very well that AB by PQ, which is equal to, yes, BC by QR. Look at this now, BC by QR. From the data that these two triangles are similar, therefore their corresponding sides are set in the proportion. Equation 2. In this by comparing these two triangles, we have got equation 1. From the data, by giving these two similar triangles, we have got corresponding sides are in the proportion. In these two equations, look at this now, LHS terms are equal. When LHS terms are equal, their RHS terms must be equal. So, from 1 and 2, yes, we say that AM by PN, which is equal to BC by QR, we have got it now. Now, see, we have got what we have got it now. See, area of the triangle ABC by area of the triangle PQR, which is equal to, see, we have got here BC by QR, yes, into, you know that here AM by PN is there. We have got AM by PM as BC by QR from that we are going to substitute BC by QR, which is equal to BC into BC, BC square, QR into QR is QR square. You need not take all the three pairs, any one pair of the corresponding sides you can prove. That means we have proved that the ratio of the areas of two similar triangles is equal to the ratio of the pairs of the corresponding sides. That's the theorem. Based on this, we can work out some other sums from the next exercise. Let us see how it is now. This is second theorem in the chapter. First theorem is Hell's theorem or basic proportionalism. This is based on the single triangle. Second theorem. Look at this now. Now, first sum, how we have to do, look at this now. If triangle ABC is similar to triangle DEF and their areas be respectively 64 square centimeters and 121 square centimeters, if EF equals to 15.4 centimeters, find BC. They have given that. Yes, triangle ABC is similar to triangle DEF. When they are similar, corresponding sides are said to be in the proportion. That means, you know that here, AB by DE, look at this now, first two letters, BC by EF, which is equals to AC by DF. They have given that these two triangles are similar. And they have given that for you EF is equals to how many centimeters here? 15.4 centimeters. Corresponding side of EF is BC. We have to find out. Look at this. BC and EF are a pair of corresponding sides. You know the theorem too. The ratio of areas of similar triangles is equals to the ratio of their corresponding sides by using that theorem too. So by theorem we know that concept area of a triangle ABC by area of a triangle DEF is equal to the ratio of the corresponding sides. They have given about this the measurements of this pairs of corresponding sides. We are going to choose now. Therefore, BC square by EF square, because the corresponding sides you have to choose now. Let us substitute here there now. Area of the triangle ABC they have given as 64 square centimeters substitute. Area of the triangle DEF 121 square centimeters, and BC is equals to they have given now here EF is 15.4 centimeters. They have given now. BC I have to find out. BC we do not know. Therefore, BC square is equals to EF square. EF is 15.4 whole square. Now we have to solve for BC. How we have to do? Yes. Therefore, BC square is equals to, look at this now, 64 by 121 into, if I do the cross multiplication, this goes to the numerator. 15.4 whole square can be written as 15.4 into 15.4. Let us simplify if possible here. Therefore, here see what to do. BC is equals to square root of 64 by 121 into 15.4 into 15.4. If I take down s square root for this now, root 64 is nothing but 8. Root 121 is 11 into 15.4 into 15.4 means only one measurement you have to take 15 point. It is a perfect square, no? Therefore get it now. 11 ones are 11. 11 ones are 11. 4 is 44. 11 fours are 14 8s are 112. 11.2 centimeters. This is the way you have to find out the length of the corresponding side of the triangles here now. Next, one more sum we can take up now. Yes. Let me draw the figure now. Yes. In this figure, ABC and DBC are two triangles on the same base BC. If AD intersects BC at O, show that area of the triangle ABC by area of the triangle DBC is equals to AO by DO. That's what they have given. Now, what you have to do now? Look at this now. Very clear they have given. Yes, triangle ABC and BDC are on the base BC. They only are given for that. What small construction you have to do? Draw, yes, perpendicular here now. Draw AP perpendicular to BC and DQ perpendicular to BC here now. Construction you have to do. Draw AP perpendicular to BC. Similarly, draw DQ perpendicular to BC. We have to draw the perpendiculars here now. So these two triangles are there, no doubt about it. What is the formula to find out the area of the triangle? In the previous session, we had discussed that area of the triangle equals to half into base into height. Therefore, area of a triangle, yes, area of a triangle ABC by area of a triangle, yes, DBC. Formula half into base into height. In the triangle ABC, when BC is the base, AP is the height. Because AP is perpendicular to BC, construction is there. Half into BC into AP. Why? In the same way, in the triangle BCD and DBC, BC is the base. Half into BC into height is DQ. Half and half gets simplified. BC and BC get simplified. Then you got AP by DQ. You have got to keep it as it is here now. Fine. Now what you have to prove? You have to prove that area of the triangle ABC by area of the triangle DBC equals to AO by DO. For that, these two triangles we have to compare. Now in the triangles, fine. Now in the triangles APO and DQO. You know very well that angle APO equals to angle DQO from the construction they are right angles. Choose now those two. Angle APO which is equals to angle DQO. Reason is there construction. Yes, at the beginning only we had done. And you know that angle AOP is equals to angle DOC. Why? They are a pair of vertically opposite angles. So angle AOP is equals to angle DOQ. Reason vertically opposite angles. As you know that by AA criterion, in the previous session we have discussed about the criteria of the angles. There are many criteria, we know that. So by AA criterion, triangle APO is similar to triangle DQO. When two triangles are similar, you know that the corresponding sides are said to be the proportion. That proportion here AP by DQ is equals to, yes, PO by QO. Look at this now. Angle A equals to angle D, angle P is equals to angle Q, and O equals to angle O. When you write this versus in a corresponding way, it is easy to compare the angles and the corresponding angles always one. See, AP by DQ is equals to PO by QO is equals to AO by DO. AO by DO. What are to prove this now? Look at this now. Area of the triangle ABC by area of the triangle DBC is equals to, already I proved that here. AP by DQ or not? Look at this now. AP by DQ. But same AP by DQ we have proved that as here AO by DO. That's all we have to prove. We have reached our target. This is the way we have to do the sums. Next sum, how we have to go for that now? Yes. Next, if the areas of two similar triangles are equal, prove that they are congruent. They are given the two similar triangles. Let triangle ABC, yes, is similar to triangle PQR. So what that if the areas of two similar triangles are equal, they are given that areas are equal. Prove that they are congruent. How do you prove now? You know, by the theorem you know that how to write area of a triangle ABC by area of a triangle PQR. You know that by theorem the ratio of the areas of similar triangles is equals to the ratio of the square of the corresponding sides, we know. Therefore, there are three pairs of the corresponding sides. AB square by PQ square, BC square by QR square, AC square PR square, anyone you can write, no problem at all in this now. Therefore, I can say AB square by PQ square. According to that theorem I had done. As they have given that these two similar triangles are equal in area. That means area of the triangle ABC equals to area of the triangle PQR. Therefore, these two get simplified. That means, what is the reason here? Area of the triangle ABC is equals to area of the triangle PQR. When both the areas are equal, you can simplify. You can get now. Look at this now. 1 by 1 is equals to AB square by yes, AB square by PQ square. Do the cross multiplication now. What you can get? AB square is equals to PQ square. When powers are equal, bases must be equal. Therefore, AB is equals to PQ. Similarly, when I have taken AB and PQ, we have got it now this. Similarly, you can prove that BC by QR also you can prove BC by QR. Similarly, you can prove that AC by PR also. There are also pair of corresponding sides AC by PR. Now look at that now. Sides of the triangle ABC are equals to the sides of the triangle PQR. Therefore, by yes by S postulate. Yes, we say that triangle ABC is congruent to triangle PR. That's what you have to prove. That means you have proved that areas of similar triangles are equal. Then we have proved that they are congruent by SSS. Postulate, we have proved that they are congruent. This is the way we have to do the sums here. Next. Next one, prove that the area of an equilateral triangle described on one side of a side is equal to the half of the area of the equilateral triangle described on one of its diagonals. So, prove the area described on one side of a square. Now we can take it as ABCD is a square. Yes, in a square, all the angles are right angles and all the sides are equal. I am taking this is A units. This is also A, this is also A, this is also A. Then we have to prove that yes, on one side of a square, see area of an equilateral triangle described on one side of a triangle. Now you can take one equilateral triangle one side, name it as AVP. Therefore, it is an equilateral triangle, all the sides are equal, it is an equilateral triangle. We have to prove that is equals to the half the area of the equilateral triangle described on one of diagonals. Diagonal you can take here now. BD is a diagonal. Draw one square on this now. Therefore, yes, DB now QR is another square. We have to prove that area of this triangle equals to half of the area of the square on the diagonal BD prescribed. That's what I have to prove. Now, yes, what I have to prove? In the figure, ABCD is a square. ABCD is a square. Let AB is equals to A units here now. So, I have taken one side equals A units now. Now see, angle in the triangle BAD, angle A is 90 degrees. Therefore, it is a right angle triangle. So, we can apply the Pythagoras theorem. So, in the triangle, yes, BAD, angle BAD is equals to 90 degrees. By Pythagoras theorem, square on the hypotenuse what now? BD square is equals to AB square plus AD square. You know that? AB is equals to A units. AD is also equals to A units here now. Yes, therefore, now AB is A units, I got it A square. This is also A square. This is equals to 2A square, I got. Square on the diagonal BD. Yes, you have to calculate. BD square, we have got it now. Square on the BD means yes, 2A square, I got it now. Now, what is the area of the ABB? Is an equilateral triangle. Area of a triangle. Area of a triangle ABP. What is the formula? to find out area of this triangle. You know area of an equilateral triangle is a square by 4 into root 3. When AB is a units now, formula a square by 4 into root 3 square units. You have got it now? Equation 1, equation 2. Now, what have got it? What is the length of the BD? Can you tell me? BD square is equals to 2a square means BD is equals to what? 2a square. You can get correct now. BD is equals to root 2 into a units. You can get now. What you have to prove at the end? Can you tell me? Yes. Yes. One of the square is equal to half the area of an equilateral described diagonals. Half of this, can you tell me? Half of this. How do you describe it? Tell me. So area of the triangle ABP is equals to half into, yes, half of the area of the triangle, area of the square on the diagonal BD, half into area of the square, yes, DB QR. You can substitute the values. What is the area of the triangle ABP? You have got it now. A square by 4 into root 3, half into area of the square. How much you have got it? Area of the square. On BD square means BD you have got it now. This you can substitute. Then you can get now root 2 into a whole square. Can simplify. Half into here root 2 whole square is 2 into a square. Then you can get both the areas are equal. This is the way you have to do the sums here now. Okay, fine. Now, yes. Now, in this chapter, we have discussed some of the sums based on Thales theorem and areas of similar triangles. In the next session, I will be taking up Pythagoras theorem. Yes, please subscribe. Let me see in the next session. Once again, thank you.